Okay, in this video we're going to look at a few more things that Python can do when it comes to math. We're going to look at some functions, remember those small inbuilt programs that we can use to manipulate numbers in order to give us some sort of result. We're also going to look at a very new concept, the concept of importing modules. First thing I'm going to do now is write import math. What this does, okay, let me begin by explaining what a module is. A module is a simple packet or package or bundle or group of even more functions which we can use in Python. Because Python would otherwise crash or be overloaded if all these functions would be permanently available, we have to import them at the beginning of our program or here at our live shell in order to use them. With this small, tiny, beautiful line which reads import, the name of the function, and math, the name of the module which we want to import, we can press enter and we have imported all the functions that are included in the math module. The math module obviously has a bunch of functions that help us manipulate numbers. We are going to try and find the square root of 16. So we create a variable, an integer variable without the quotation marks, reading x, the name, is equal to 16. And now we have, x is equal to 15. We want to find the square root of this. Luckily for us, since we're very lazy, luckily for us, the module math has an inbuilt function which we have now imported, with which we can find the square root without even having to do any thinking or math of our own. To access this function, which is located inside the math module, we use the already known dot notation. We begin by writing math, the name of the module, the name of the packet or the gathering in which the function is. By this, Python knows, okay, I'm looking for something in the math module. Then we write sqrt, which stands for square root. This is the name of the function which is located in the math module. Then we give it the brackets and add the parameters. Now obviously to square root something, the function needs to know what it's supposed to square root. So we want it to square root x, which is 16. We press enter and get an answer. Our answer, 4.0. Note once more that the answer is given as a float, not as an integer, because there's a decimal. This is done because when square rooting stuff, most of the time it's not going to work out beautifully like 4, but going to be some weird long number with loads of decimals. This is essentially the same thing that we've been doing with strings. Remember the index or count functions? Same story, with one difference. These functions have to be imported and then through dot notation accessed via their modules. Another one that we can use is basically the opposite of the square root, which is to raise something by a power or something. Let us raise 16 to the power of 7. Since of course we could write 16 to the power of 7, which we have seen how to do before, but we want to be cool and we want to use a module. So we go into math, because that's where this module is, that's because this function can be found. Math is the module name. Then the name of the function, which surprisingly is called pow, meaning power. The brackets in which come the arguments, the parameters which this function needs. Now, what parameters might a power function, like a power to raise something by the power function, need? We need a number which is going to be raised, and we need a number by how much this number is going to be raised. So we begin by giving it the 16, which is the number to be raised, and then the 7, which is the number by how much it is raised. So this is 16 to the power of 7. We press enter and we get the exact same answer as above. Now this may seem rather useless, but in the long run this is useful when working with many variables and when using functions to create functions, etc. All stuff for the future. Of course we can also use x, our variable, in this function in order to make life a bit more easy for us, and we will get exactly the same result. These functions, there are numerous ones of these. There are ones for sines, for cosine, for logarithms, for tangents, for everything. There's a math module. The math module includes a lot of very useful mathematical functions which we can use and will have to use in the future in order to make our programs work properly. Of course, in Python, there are also many other modules, these packets of functions. There are modules to create random numbers. There are modules to edit pictures. There's modules to create text files. There's okay, maybe not hundreds, but dozens of modules which we can access through Python. Many of them are very specific modules and are only needed for some things. Some are more general, like the math module, but definitely all of them save the programmer a lot of work because they include a lot of functions that can do work for us. And since we're lazy, we like it.